Hello, Munchkins. All right, let's do operations on functions. Today, or tomorrow, or however you do this, you're going to find the sum, difference, and product and quotient of functions. In other words, you're going to add, subtract, multiply, and divide. And then you're going to find the composition of functions, which means you're going to put one inside the other. Oh my gosh, this looks like it could be so hard. Hey, dear, no, let's find out. Okay, so what's going to happen is I'm going to give you an f of x and a g of x. In other words, I'm going to give you two functions. And they can change up, but I'll keep it like f of x, g of x, saying f is 1, g is 2, or whatever, you know. Anyways, we're going to define f of x to be x squared minus 4, and g of x to be 2x plus 1. So how do you add those two together? Well, that's a good question. Let's see. Oh, it looks like all I got to do is add them up. Now look, what I would do is I would first take each function and put a plus in between them with them in parentheses. Then go ahead and try to combine your like terms or whatever. In this case, like, okay, nothing goes with x squared, so I'm going to say x squared. Nothing goes with the 2x, so I'm going to say plus 2x. And then minus 4 plus 1 would give me negative 3. And then I might do the same thing if I said minus. Okay, minus, I'll do the same thing, but I'm going to put a minus in between the two. And what's that minus going to do? It's going to change the sign of everything in this second parentheses. So now I have x squared, but the minus is going to change that 2x to a minus 2x. Oh, well, I went ahead and made the changes. So I went ahead and distributed this here. Whoops, forgot that. And now I'm going to combine. So now I can say x squared minus 2x. And now I'm saying negative 4 minus 1, which is negative 5. Now notice here that you don't get the same answer when you add versus when you subtract. Let's look at another example. Okay, so here I'm going to say f of x is equal to, say, x squared plus 5x minus 2, and g of x is defined as 3x plus, I can't read, 3x minus 2. So if I add these two together, again, that's like saying that I'm adding. Well, that is adding. And I just add them together. Now, maybe you do this like, whoa, let's put the like terms together. Let's line them up. So here I am lining them up. Notice a plus does not change the sign. So I can say x squared, so 5 plus 3 is 8x. Negative 2 minus 2 is negative 4. I know, extremely hard, right? F minus g of x. Same thing, but this time as I move them under, I'm going to change the signs. So that becomes minus 3x, and that becomes a plus 2. Okay, x squared minus 3 plus 2x, 5 minus 3 is 2. And then negative 2 plus 2 is 0, which I don't need the 0, so I can just get rid of that and just say there my answer is x squared plus 2x when I subtract the 2. Pretty simple, right? All you got to do is add or subtract. It's combining like terms. All right, multiplication. What happens when you need to multiply? Okay, so here I'm going to multiply these two. X squared plus 7x plus 2, or plus 12, sorry. 3x minus 4, and I'm going to multiply the two. Notice that there's nothing in between, because multiplication is the only one that you can do without having to put something in between it. I'm going to do this in the vertical method, but again, you have different methods of multiplying. So here I would say, okay, 12 times negative 4 is negative 48. Negative 4 times 7x is negative 28x. Negative 4 times x squared is negative 4x squared. Start on the second row, put a 0, and then start with the next number. 3x times 12 is 36x. Notice how these line up. 3x times 7x is 21x squared. And 3x times x squared is 3x cubed. Then I can just combine my like terms, and there's my multiplication. And that's really about it. It's not anything that should be overly difficult. And that's it. Oh no, now comes the dividing. Those fractions. What do I do? Okay, look, it's fractions. It means divide. So put the f of x on top. Put the g of x on bottom. And that's pretty much it for now. Later on, we will see what we can do further with that when we get to rational functions. No, not rational functions, which means nothing but fractions. Anyways, but we do need to make note here. The denominator, the 3x minus 4, cannot equal 0. So I need to solve it like saying 3x minus 4 equals 0. So I get x equal to 4/3. Add the 4 and divide by 3. The thing is that that right there, I can't have it be, because if I put 4/3 in here in place of the x, I would get an answer of 0, and I can't divide by 0. So I have to make note that this is the dividing, but that x cannot be equal to 4/3. Anytime you have an x on the bottom, you need to make note of what x cannot be equal to, because you have to identify that. All right, so composition of functions. Composition of functions is essentially putting one function into the other. My biggest thing with this was always like when they would go f o g of x or g o f of x, this little open dot. What did that mean? Well, okay, that basically means this is on the outside and you're putting the g1 into the other one. Or if it's G first then F, then you're putting the F1 into the G. So that's why I kind of rewrite them like this. So that way you know this one goes in to the other one. Okay, what do I mean by that? Well, let's find out. Beep. Okay, so here's two functions. F of x is equal to 2x minus 5 and G of x is equal to 4x. So if I say G a composite of F or F composite of G, I don't even sure how that goes again. Basically, this means I'm going to put this function into this one. Okay, what that means is that instead of having an x here, I'm going to put 4x in place of that x right there. I'm going to substitute it in. But I'm going to keep everything else the same. So notice here, I've just gotten rid of the x. What am I going to put in place of the x? I'm going to put in place what G was, which is 4x. And then I could say distribute and get 8x minus 5, and that is the composite. That is the combining of the two functions. Well, what happens if I switch them around? Okay, now I'm putting the f into the g. So in other words, instead of saying 4x, I'm saying 4 blank, and I'm going to put this 2x minus 5 in place of that. So I'm putting this whole function, the whole thing, in place of the x here. Okay, now that gives me 4 times 2 is 8x. I can distribute, and 4 times 5 is negative 20. And there you go. So notice that the answers are slightly different, but they almost look kind of the same here. One more example, and then we can be done. Yay! Yeah! Oh! All right, so here's an f of x, here's a g of x. Let me combine the f of x, or fg of x. FG of x. I think that's how it goes. Anyways, excuse me. So I'm going to put here, instead of an x, I'm going to put, notice I got that blank. Okay, so now I'm going to put what g was. G is 3x minus 7. Okay, so there's nothing to distribute, so I can drop the parentheses, say 3x minus 7 plus 5 gives me 3x minus 2. Too fast. Okay, so all I had to do was combine those two and got that answer. Okay, so now let's look at the other one. What happens if I switch things around? Okay, so instead of saying 3x minus 7, I'm going to say 3 blanks minus 7. And now I need to put something in place of the x. So what is f equal to? X plus 5. So I'm going to put here x plus 5. And again, distribute. And then I would combine the 15 and 7, so that gives me 8. And there's my final answer for that one. So that's really about it. Should not be that difficult. Hopefully after all y'all's fretting with, say, factoring, we can get to this one and y'all be able to understand this fairly well. Anyways, that's it for today. Thank you so much for listening, and thank you so much for your attention. Y'all be good. Y'all take care.